integrating cosine squared and sine squared. Let's look at an example with cosine squared. Cosine squared of 11x being the angle with respect to x. We could actually rewrite this as cosine of 11x, all of it to the power of 2, because that square belongs to the cosine only, but sometimes the shorthand gets a bit on the way. So anyway, what do we have to do? That square, that's the problem. So we have to find a way to rewrite cosine squared or sine squared as a different expression that does not contain the square. So what we have to do is go to the formula sheet and look for the page on trigonometry that has the double angles. So what do I mean by that? Double angles, so the formulas you will see there are 3 of them, start off with cos 2a. The first one is cos squared minus sine squared. The second one is 2 cosine squared minus 1 of the same angle we're talking here as a generic angle. And the third one, it's close to the bottom of the page, 2 sine squared a. So all of these, the second and third, also mean 2a, cos of 2a. So this is what we mean by double angles, 2a here. So let's look at which one we should use for this exercise. Well, the very first one is not good because we have the cos squared of a, but then we also have the sine squared of a. So we are removing the problem of the cos squared, but then introducing another problem, which is the sine squared, which we cannot integrate. So that is not a good one. So let's look at the second one. The second one has cosine squared and it's looking really good for this exercise here. So basically what we have to do is rearrange the formula to get the purple bit, cosine squared a, on its own, and then we can substitute up there in the exercise. We'll just have a look at the last one, even though we're not going to use it right now. The last one has sine squared only. So that means if we were to integrate an expression with sine squared, this would be the one we would use, and we would also rearrange the formula to get sine squared on its own. So let's start again and let's write here the original integral, cos squared of 11x, and of course integrated with respect to x. So I'll just now copy that formula from the formula sheet. So I'm just doing like writing in the margin, or just having a little extra activity here, writing cos 2a, just copying the second formula, equals 2 cosine squared a minus 1. So what we need to do, as we said before, is rearrange the formula for that. Because it's a positive coefficient, let's leave it all there, and let's add 1 to both sides, so we can eliminate that negative 1 from the right hand side. So what do we have? Cos 2a plus 1 equals 2 cosine squared a. Here we are. So now we are almost there. Cosine squared a is almost isolated. So what we need to do now is remove that 2, which is multiplying. So what we do is we divide both sides by 2. The whole side here is divided by 2. So look at that. This cos squared a, that one there as well, will be able to be rewritten as cos 2a plus 1. The double angle here is something we can integrate. It's not a square anymore. So let's apply it. So writing the integral once again, cos squared of 11x dx. First thing we do is we're going to rewrite this expression here. So let's put integral. Instead of cos squared, we actually rearranged the expression and said it would be cos of double angle 2a. Well, I have to use what I have here, 2a. In this case, a is 11x. So 2 times 11x, or 22x we could put straight away. So cos of double angle, and then what did we do? Plus 1, all of it divided by 2. So that's when we had in the previous slide the cos squared a isolated. Add 1, divide by 2, dx. So one thing we could do here is separate this integral into 2, because we have the first term here before the plus and the second term there, both over 2. So we could rewrite this as cos of 22x over 2 plus a half, all of that integrated. So here we are. Now we are talking, we can integrate that sort of thing. So this half that we see here over 2, there is like an invisible half. I can write it just at the front because it doesn't need integration. It's just a coefficient of that cosine. But now I'm going to do cosine. What's the integral of cosine? Go to the formula sheet if needed. Sine of 22x. So cosine, sine, we can do that. That's a standard integral. But because now we have this linear function, like this is a composite function, 22x, if we were differentiating, we would multiply by that derivative. Here, because we are integrating, we divide by that. Done. So this very first term has been fully integrated. Now let's integrate the half. Half is a constant. So integral of constant, just we bring back the x, isn't it? So we will do plus a half times the constant. Sorry, plus a half times the x. And then plus a constant at the very end. So let's see how this is going to look now. Let's try to rewrite it. Those two numbers here on the bottom, because there is a multiplication that half is timesing. So 2 times 22, we're going to have 44 on the bottom. So we could say, final answer here, sine of 22x, that's the angle, divided by 44, plus half x, or x over 2, plus a constant. So this is the integral of cosine squared of 11x with respect to x. Mainly what we need to do is rewrite cosine squared as a double angle formula.